Hello, this is going to be lesson B17, square root property and completing the square, also found in section 12.1 of your textbook. Here I have an example 1, which asks to solve the equation x squared equals 9. Up to this point, we learned two ways to solve an equation like this. The first method was by factoring. Basically, I moved the 9 to the other side, and basically I recognize that this is a special factor, x plus 3, x minus 3. And basically I break it down to 2 as x plus 3 equals 0, x minus 3 equals 0, and when I solve for x, the 3 goes the other side, so it becomes negative 3, and 3 goes the other side here and becomes positive 3. So my two answers are negative 3 and 3. The second method was the quadratic formula, which uses this formula right here when the quadratic function is equals to 0. So first thing I do is move the 9 to the other side. That way, I know that my a is 1, my c is negative 9, and I don't have a b, so I'm going to call b 0. So as you can see, when I plug it in, b is 0, a is 1, and c is negative 9. So when I solve it, I get the same answer as factoring. And now we're going to talk about the third method, which is the square root property. Basically, square root property says, if you get the x by itself, the x squared by itself, basically what you can do is take the square root of both sides, but you have to remember to put a positive and negative in front of the square root. And on this side, the x gets to be alone, and on this side I have positive and negative. Square root of 9 is 3. Alright, so let's take a look at some other examples here. I have example number 2, okay, where we're going to use the square root property to solve the following equations. So here I have 2x squared minus the 100 equals 0. So first thing I need to do is get the x squared alone. So I move the 100 to the other side. And I divide both sides of the equation by 2. So that way I get x squared equals 50. And once the x squared is by itself, I take the square root of both sides. And on this side, remember to put positive and negative. 50 is not a perfect square, so I did the prime factorization. And I got 5 squared times 2. So that means this 5 squared goes away, and the 2 stays inside the radical. So my answer is positive negative 5 square root of 2. Okay. This over here, I have, I started out with x plus 3 squared equals 20. So first thing I need to do is take the square root of both sides. Remember to put positive and negative. Square root of 20 is not a perfect square, so I broke it down 20 as 2 times 2 times 5, which is 2 squared times 5. On this side, the radical cancels the square, so I'm left with x plus 3. Also here, the 2 squared comes out as 2. And to get the x alone, all I have to do is move the 3 to the other side, so it becomes negative 3. Okay, and here it was just like disregard this part right here. Okay. By the way, here I was trying to show to the class that there's actually two answers here. It's negative 3 plus 2 square root of 5 and negative 3 minus 2 square root of 5. And basically, we can write it this way with the positive and negative, or we can break it down into two answers. So depending on how it is on the multiple choice, you would pick accordingly. Alright, the next problem then will be about 5x minus 2 squared equals negative 9. So because I have a square here, in order to get rid of that square, I can take the square root of both sides. If you notice, I put the positive and negative. And square root of 9 is 3. And the negative comes out as letter I. On this side, the square root cancel the square. So I'm left with 5x minus 2. And this time I need to move, get the x alone, so I move the 2 to the other side, and then I divide it by 5, and then that's my answer. Alright, the last part of the lesson is about completing the square. Completing the square has to do with those special factors that we learned. A plus b squared equals a squared plus 2ab plus b squared, and also a minus b squared equals a squared minus 2ab plus b squared. Basically, we need to keep this in mind. So let's look at an example here. I have x squared plus 4x equals 3. Basically, I'm going to keep the 3 on the other side, and basically I'm going to try to complete this square. If you notice, the middle term is 2 times the square root of the first, and to complete the square, what number would have to be over here? Basically, I'm trying to guess what number would I have to multiply 2 times x to give me 4x. And I say, well, it's going to be 2. So 2 times x times 2 would give me a 4. So if this second number here is 2, according to the formula, we have the first one squared plus 2 times the first times the second plus the second squared. If we determine that the second has to be 2, then this guy here would have to be a 4. So therefore, on both sides of the equation, I'm going to add the 4. And now, I have completed the square, so instead of writing this, a trinomial, I can write x plus 2, open parentheses, squared. So basically, I notice that this guy here would be this, and because this is the same as that, I can rewrite this as x plus 2 x plus 2 squared. And my goal is to get the x alone, so what I'm going to do is going to take the square root of both sides, and this becomes x plus 2, and here I get positive negative square root of 7. And then all I have to do is move the 2 to the other side, and that's my final answer right there. Okay. Here I gave another example to the class. Basically, if I had 25x squared minus 40 plus 2, what I would do is I move the 2 to the other side, becomes a negative 2, and I'll try to guess the third term over here. See how this is underlined? It's because I'm trying to come out what number I should put on both sides of the equation to complete this square. How do I know this is a perfect square? It's because I noticed that this is a perfect square, 25x squared, and I'm trying to see if I can complete this square. So how do I do that? I write the 2, I open 2 sets of parentheses. The first parenthesis I can fill in with the square root of this guy right here. Square root of 25x squared is 5x. And now my job is to complete this little parenthesis here that there's no number. So basically I ask myself, 2 times 5 is 10. 10 to get 40, I need to multiply by 4. So I know that my second term here has to be a 4. And if this is a 4, that means this guy here is 4 squared. So 16. So then I know that I can add I can add 16 to both sides of the equation to complete the square. Once I complete the square, I can rewrite this trinomial as 5x minus 4 raised to the square. Negative 2 plus 16 is positive 14. I take the square root of both sides. The square root cancel on this side with the square. I'm left with 5x minus 4. On this side I get positive negative square root of 14. Then all I have to do is solve for x. So move the 4 to the other side and then divide it by 5. Okay. Alright, let's take a look at an example here. Here I had x squared minus 6x equals 11. And I want to complete the square, so basically I set up 2, open 2 sets of parentheses. The square root of the first is x. What would I have to multiply? 2 times x times what would give me 6. So basically I don't know what number this is. So what number multiply 2x to get 6? Well, 3. And if that is a 3, then this number would have to be 3 squared, which is 9. So on both sides of the equation I'm going to add a 9. So this x squared minus 6x plus 9 becomes x minus 3 squared. And on this side I get a 20. And to solve the equation, then basically I take the square root of both sides. Don't forget to put a positive negative there. And square root of 20, I did the prime factorization over here. And I know that this is the same as 2 square root of 5. And all I have to do now is move the 3 to the other side. Okay, last example. We have 25x squared plus 40x plus 3 equals 0. First thing I'm going to do is move the 3 to the other side, and I'm going to put a little empty line right here because that's what I'm trying to add to both sides. I set it up with 2 times 2 empty parentheses. The first parenthesis I fill in with the square root of this. The second parenthesis I ask myself, 2 times 5 is 10x. To get to 40, I need to multiply by 4. So I put in a 4 there. And if that's a 4, then this would be 4 squared. So that means I'm adding 16 to both sides. I can rewrite this trinomial as 5x plus 4 to the second power equals negative 3 plus 16 is 13. To get rid of this square, I square root of both sides. And basically I just solve for x. Move the 4 to the other side. Divide both sides by 5. And that's my answer right there. I tried to show the class that if on the final exam or on the test you forget how to complete the square, you can always use the quadratic formula. And here is an example where I did the same exact problem using the quadratic formula, and I came up with the same answer as doing by the completing the square. So this concludes the course. I mean, this is the last lesson of the course, and basically now the assignment is to do these problems out of the final exam review. 3 problems you're going to use the square root property. The next 2 problems you're going to complete the square, and the last 3 you're going to use the quadratic formula. Thank you very much for your time, and have a great day.